Evening students. Today this is the 12th video of elasticity. We are going to discuss work done per unit volume of a material. Right? Say example, you take a material in the form of a wire. Right? This is a wire. And here A is the area of cross section. L is the length of the wire. Now a force, a constant force or a weight, or we call it's called load. Load is what? Mass into acceleration is added. What will happen? Here the wire gets stretched. There is an increasing length. There is an increasing length. Suppose this 100 centimeter, 3 millimeter increases by adding 3 kg. It's like that. This is also called extension, you can call, or elongation. And within elastic limit, the area almost constant because area remains same, you can call. Therefore, what is stress or longitudinal stress? Stress is equal to what? Force per unit area. And what is the longitudinal strain? Longitudinal strain is what? Increase in length by original length. According to Young's modulus, Q is equal to stress by strain, that is longitudinal stress and longitudinal strain. Stress is what? Force per unit area, increase in length by original length. All these things we have done several times. We are repeating. This goes up. Therefore, Q is equal to F, L, small l and A. You got it. Now you isolate that force. Q is the constant. Therefore, what is F? F is equal to Q, A, L by capital L. Here what happens as when you increase the force, the extension also get increased. When I add 3 kg, 3 millimeter, 4 kg, 4 millimeter. Right? Area slightly decreases, but it's negligible. Within elastic limits, this area is always constant. We assume that even area also changes, but within elastic limit, we'll do that. Now, what is the work done? Small amount of work done in further extension of small length. If I, instead of for 3 kg, I get 4 kg, another 1 millimeter increases. Therefore, what is the work done? Work done is equal to force into displacement. A small increase in length is equal to small amount of work done. Then what is the total work done? Total work done in extending the wire from zero length to some specified length of your specified line within the elastic limit is equal to adding all the work done, right? That is equal to 0 to L work done is equal to F dl. I'll write it. Then you substitute this F here. The F you substitute here. Therefore, work done is equal to 0 to L Q A L small l. Just I substitute F here and dl. Now these all are constant. I'm taking out of the constant of integration. See, A by L, I have taken it out. Integral of 0 to L dl. Now you know this integration of x dx is equal to x square by 2. You know this. Instead of x you got L, isn't it? Therefore, here what I write? W is equal to QA by L. This is L square by 2. Lower and upper limit you substitute. As a result, what you'll get? Work done is equal to QA by L. L square by 2, you get it. And again what I write? QA by L. L square can half, I'll take it out this side. L into L. Now, what you observe from this quantity? This quantity is same as this, isn't it? This quantity is same as this. Therefore, instead of this, I am going to put F here. Therefore, half F into L. Therefore, work done is equal to half into load into extension. Can I do like this? Work done is equal to load into extension. Okay. Okay. See, I am working out all in the waste paper only, right? Whatever. Therefore, work done is equal to half load into extension. Then work done per unit volume of the material. What is volume of the material? Volume is equal to area into L, is it not? What is this? Area into length. Volume of the cylinder, you will get it, right? Volume of cylinder. A into L, that is what? Volume is equal to area into length, you get it? V is equal to A into L. That one I am going to do this. Work done is equal to half F into L by A, V, work done per unit volume. That means half F into L. Area is what? Area into capital L here. Or half F by A and small l by L. Can you follow? Force per unit area is equal to what? Stress. Longitudinal stress. This is increase extension by original length is called strain. Therefore, work done per unit volume of the material is equal to half into stress and strain. SS is taken so much strain for you to understand 50% of the portion at least. You remember, okay? Here, this is not only this, I have taken longitudinal stress. This is applicable for shearing stress also and bulk modulus, volume stress also. All that it is applicable, right? This is true for all the value. Therefore, what I do is, this in the examination they may ask you for 2 marks or 3 marks. Just I write work done in stretching a wire. Okay. Or prove that work done is equal to half load into elongation. They may give like this. Load into elongation. Load is what? Force is equal to mass into acceleration. Mass into GL, you can do it. Or work done per unit volume of the material is equal to half stress into strain, they can ask you. I have written this. And all these things are expression. Whatever I have written in the word. Sentence. You have to write, this is what you decorate with the sentence. Because this is like a skeleton. You have to put a muzzle and give a life for it. Simply some students they write like this. It is like a skeleton. It is not easy, right? You are putting what? That muzzle, life and makeup and all that you have to put it to please the examiner. Okay. Therefore it may be 3 marks or 4 marks. Work done when your body is stretched. And handwriting should be perfect. Some students they can do what other people cannot do. That is, they can read their own handwriting. Other people cannot do it at all. It is not like that. You have to write the handwriting in such a way that what? Other examiner also must understand what you written. That was when a body is stretched, it gets strained. The work done in stored in the form of potential energy or energy of strain. And see, this is the sentence you have to add it. Consider a wire of length L, area of cross section A, and being stretched by applied force F or load. This results in the increasing length L. Because I am reading out so that you can write your own. Therefore, since space conservation is more important. Right? That is why I am writing demarcations here, there. Got it? Don't merge. Put a line here if you want in the examination. And put all this such a way that this one things. Young's modulus is what? Stress by strain. No, examiner they won't understand. Here only write it. Stress is equal to force per unit area. Strain is equal to elongation by increase in length. That I have written here. Everything I have written. Got it? And more precise it should be. Q is equal to F by L. This I have written. The work done means stretching the wire by further small length. By a further small length is equal to DL is equal to work done. Work done is the force into displacement I have written. The total work done, see this is total work done. What is that? Total work done in producing the stretching of the wire from 0 to desired length. 0 to desired length, whatever the length you wanted, but within the elastic limit. That is important. Within the elastic limit. That's written here. So that, right? This Q is comes out as a constant. Remaining all mathematics, whatever I have done here. See, you remember. That's why bubble stripe I have written all this for you, right? Got it? Therefore, you have written, okay? You remember this. In comics only you'll get all this. But anyway, don't write all this comic picture and all that in the exam. I have written for you to understand. See here QA, QL by all these things you write it. Then what? L square. Then remaining and all, it is easy for you to do this. Right? This much you stop. Therefore, it may be you fetch you for 3 or 4 marks. Okay? Therefore, just take the screenshot of this. Please take the screenshot. Okay. I'll be sending you the PDF also for this.